Welcome to Vax Productions presents Circuits. Circuits can be a very complicated topic, but with the following analogy, namely the respiratory system, we will simplify it for your needs. In this analogy, blood vessels will be equivalent to wires in the circuit. The oxygen will be the energy. Red blood cells are meant to represent the electrons. Light bulbs in our analogy will be represented by muscle. The alveoli you see are meant to represent a battery. And in some cases, you'll see plaque as a resistor. The following image is meant to be a brain, and it will, in our analogy, be either a voltmeter or an ammeter that measures volts or amps. This muscle, we'll be looking at what makes this muscle contract. These are the red blood cells. If they have oxygen, they will be red. They are moving towards the muscle. Once they reach the muscle will start to contract and get stronger. After this, they will no longer have enough oxygen, so then they'll be blue. They then make their way back up to the battery, or in our analogy, the alveoli. However, after passing through these, they will not stay blue, they will come back to red because they will have gained oxygen. This is a series circuit. It is a series circuit because the amount of electrons passing by any point will always be the same because there is only one path that the electrons can take. Or, in this case, there's only one blood vessel that the red blood cells can flow through. However, there will not always be the same amount of oxygen or voltage within the red blood cells or electrons because after passing through the component, light bulb, or muscle, they will have lost some of their energy or oxygen. Contrary to the first drawing, what you see now is a parallel circuit. This parallel circuit has two light bulbs, or muscles. These electrons are flowing, red blood cells are flowing through them. After reaching the first light bulb, they are charging it up with more energy and allowing for it to become, for the muscle to contract. The next one then also allows for the muscle to contract, to then keep flowing. This is different to a series circuit because the amount of electrons passing by any point is different throughout the circuit because there are two different blood vessels that the red blood cells could go through. So half will go through the first one and half will go through the second one. Also, the voltage within a parallel circuit is consistent throughout the entire circuit because although the amount of paths change, all of the energy is also still only used by one light bulb. This is a parallel circuit. Now we will be taking a look at resistors within circuits. The electrons, or red blood cells, cannot flow through resistors as well as without. This means that the battery will have some difficulties being able to contract as with the muscle, and so there will only be a slight contraction. Thank you for watching this educational video made by Vax Productions. We hope to see you again.